So continuing on with the solutions for the end of year review number 3, which is all about geometry, we just have a few things, getting some distances, proving that two triangles are congruent. So right here we have a proof set up for us. We just need to actually complete the proof now. So C is a midpoint of BE. Okay, so on these proofs they start out with givens. Angle B and E are congruent. That's a given. Given. Sorry, handwriting's atrocious. A, B, and D, E are congruent, and that's a given. It's up there at the top. And the next part's given as well. We need to write that down. That C is a midpoint of B, E, and it's just right up here. And since it's a midpoint, you have to remember that midpoints, well, are exactly in the middle. And so this side and this side, either side of C, those are congruent to each other. And that's because of the midpoint. So BC is congruent to CE because C is the midpoint of the whole line. And that proof's actually done now. So that one was fairly short. This one we have to start from scratch. And so you get yourself, a table here where we, on the left side, we have our statements. And then on the right side, we have our reason, or the proof. And let's start with the givens. Number 1, AB is congruent to CD. And that's a given. And we also have, let's do another one. We have that angle ABD is congruent to angle CDB, and that's a given. And we also need another congruency to have, man, my handwriting's just horrible. Given. And looking at this figure, I know right here in the middle, this side is congruent to itself. I'm going to add a couple congruence marks there. I know that BD is congruent to BD, and that's called the reflexive property. And that's the reflexive property. I'll actually write out property for you. Lets you know that the middle side is congruent to itself. And now we have some things established. We have two sides and the angle between them. So really we have side, angle, sides. So we have completed that ABD is congruent to triangle CDB by side, angle, side. And there's a little two-column proof there. 18, we find the distance between those 2 points. Remember that the distance formula is that you have to subtract the x's and square that. And then you're going to subtract the y's and square that. And that'll give you the distance. And so, I'm going to subtract the x's. That's -7 minus -4. And then I'm going to subtract the y's, so that's 2 minus 8. And we need to square those. -7 minus -4 is -3, which we'll need to square. And then 2 minus 8 is -6. I'll need to square that. If you square -3, you'll get 9. And then if you square -6, you'll get 36. And if you add those up, you'll get 45, or the square root of 45, and you can actually end there if you want, but you can put in your calculator and it'll give you a decimal approximation that doesn't come out to be a whole number, which is fine. Next we need to write the equation of a line that goes through the point right here and is parallel to this guy here. Remember that if you have a point and a slope, you can use this point-slope form to write your equation of a line, and then you can transform that into any other form that you need it. And this is the formula here. And so you're going to replace the coordinates of the points where x1 and y1 are, and then the slope where m is. So we're going to start with y minus the y value, which was negative 5. And then on the right side, we're going to have m first the slope. So if we want something to be parallel to the original one, we have to have the same slope as the original one. The original slope is right in front of x, which is 6. So I'm going to put 6 there. And then I'm going to have x minus 3, because that's the x value of my point. And I can simplify this down. Left side I'll get y plus 5. And if you distribute that 6 through, you'll get 6x minus 18. And then you can get y by itself by subtracting 5 from both sides. You get y equals 6x minus 23. And that's the equation of the line that goes through this point. You can even test it out. If you put 3 in for x right here, you should get negative 5 for the y value. And number 20, you're going to do the same thing. I'm going to start with y minus that y value, negative 1. And this time the slope's going to be different. X minus negative 6. Sorry. So I'm just using these coordinates here, those two numbers. We want a line that's perpendicular to this one, so you can take your original slope and write it well. And you need to get the opposite reciprocal of that, and that'll give you a perpendicular slope. So you turn it upside down, get the reciprocal, and then change the sign. So negative 1/6 is going to be the slope I'm going to use. And you can simplify this one down, distribute, left side becomes y plus 1. I think I could write well. Negative 1/6 times x is negative 1/6 x. And negative 1/6 times positive 6 is going to give you negative 1. And now if you just subtract 1 from both sides to get y by itself, you'll get y equals negative 1/6 x minus 2. And ta-da, we are actually done with this section.